All right, so we're going to finish up last section, the last half of section A.4, which is on complex numbers. We already learned how to add and subtract them yesterday. Okay, today we're going to multiply and divide. All right, so yesterday I talked about complex numbers, explained kind of where they fit in the big picture of all other types of numbers. And I said that this is a definition. I is the square root of -1. Okay, this is not something, bless you, this isn't something that you prove. Okay, it's kind of like in geometry when you say parallel lines don't cross. You don't prove that, it's just a fact. You've got to use that fact to do other things in geometry. Okay? We're going to use this fact to do some other things today, like defining I squared. Okay. Does anyone remember from yesterday what I squared is?
-1.
Yep, -1. That's important. So anytime you see an answer, okay, if you see an I squared in the final answer, that's wrong. It's not simplified. Okay, I squared should always be changed to -1. Any questions on that? All right, so let's leave that up for a second. And let's look at how we do a product. Okay, I'm going to set it up pretty much the same system we were using yesterday. We have two complex numbers. The first one is a plus bi. Second one is c plus di. When we're doing an actual problem, a, b, c, and d will all be numbers. Okay, and when we multiply them together, this is how we do it. Okay, does that look like anything you've seen before? Yeah, it's like some people call it FOIL. Some people say it's the distributive property twice. But that's how you do it. Okay. FOIL. All right, so we multiply a times c. Then we got a times di, c times bi, and then the last part is bi times di. Okay, we got to pay careful attention to what happens there. We have an I times an I. It's going to give us an I squared. Okay, so remember what I said about that. Okay. Any questions on this pattern? Is anybody not familiar with FOIL? Ever heard that before? FOIL, it just stands for multiplying the first terms, the outer terms, the inner, and then the last. So it's just a way to remember to multiply everything together. Anybody still copying? All right. Okay, so let's try to multiply these together. Okay. 2 plus I times 1 minus I. Now, how do you know that this is going to be FOIL, besides the fact I said multiply? How come I don't just do what I did yesterday, like combine the like terms? Yeah, Paige? Yeah, we've got parentheses. Okay, and there's nothing between them. If I change it to this is a totally different problem. This is what we did yesterday. Okay, on the test, a lot of people see this and they start FOILing. Okay, when you're adding and subtracting, okay, did we do FOIL yesterday? No. Okay, FOIL is only when you multiply. Okay, so don't start doing FOIL for everything. Just multiply. All right, Andy, what's first two things I'd multiply? Yep, 2 times 1. Okay, John, next two things?
2 and -i.
And what's 2 times -i?
-2i.
Yep, -2i. Good. Okay, Alex, next thing?
I and 1.
I times 1. Okay, anything times 1 stays the same. All right, Jake, last two things?
I'm not sure.
Well, what's the only two things here we haven't multiplied together? We did the first, we did the outer, we did the inner, So we got to do the last.
Is it I squared?
Oh, okay, you know what? Just do it one step at a time. So how did you get there? You took I times,
I.
close, negative I. Sign to the left always goes with your thing. Okay, so we've got I times negative I. First of all, it's a positive times a negative. That's a negative. Okay, I'm going to take care of that. And I have I times I. Okay, so it's negative I squared. All right. Next thing I've got is negative 2I plus I.
So negative I.
Yep, you can think of it as 1I if you want when you combine it. Okay, so negative I. Okay, now this last part. We have the minus, but what's I squared? Negative 1. Okay, and what happens if we minus 1?
It turns into a positive.
Turns into a plus 1. Right, now we can combine that with the 2. What's 2 plus 1? 3 minus A. Okay, that's how you multiply complex numbers. Any questions on that? That's it. That's how you multiply. All right, let's try one more. Okay, Nathan, what's first two things I'd multiply here?
8 and
8 and
3.
3, yep. So 8 times 3 gives me 24. Kelly, next two things? 8 and I. Okay, so that gives me 8I. Okay, Ashley, next two? Yep, so we got our first outer, now we just did inner. I times 3. Okay, we have some like terms, we'll worry about that after. Yep, and then the last part is I times I. If you want to change it right away, you can, but maybe it's better to just do it in one step at a time. Okay, so we've got 8I plus 3I. Tiffany, what would that give me?
12I.
Be careful, 8 plus 3.
Oh, 11.
Yeah. All right, so 11I, and then I squared, that's minus 1. Okay, so what's my final answer here? 23 plus 11I. Okay, any questions on that? Okay, multiplying is important because that's how we end up dividing. Okay, in order to divide, you have to know how to do this first. Okay? All right, so okay, last thing we're going to look at for arithmetic with complex numbers is how we divide them. Right, so suppose that we had this as our complex number. I'm going to call it Z, and Z is the complex number A plus BI. Okay? A and B could be any numbers you want. 2 minus 5I, 6 plus 7I. It doesn't matter. Okay, this symbol, okay, Z with a bar on top, it's called the conjugate of Z. It's called the conjugate of Z. And all the conjugate means to do is take your number and change the sign of the imaginary part. So my original number was A plus BI. The conjugate is A minus BI. Okay, so to find the conjugate, negate means change the sign of. Okay, so you change the sign of the imaginary part. Don't do anything to the real part. Okay, just leave that the same. Okay, so before we divide, we're just going to practice finding some conjugates, all right? Because in order to divide, you need to know how to do two things. One is multiply. The second thing is find a conjugate. So let's start with 3 plus 4i. Okay, if that was my complex number, what would be the conjugate of 3 plus 4i?
3 minus 4.
Yep, 3 minus 4i. So if the imaginary part's positive, it becomes negative. Okay. What about in this one? Negative 8 minus 2i. Yeah, it becomes negative 8 plus 2i. That's the conjugate. Okay. How about 5i? Negative 5i. Okay, if that one's confusing because you don't have a real part, think of it as 0 plus 5i. The conjugate is 0 minus 5i. Which is negative 5i. How about 3? 3. Okay, real part stays the same. You could think of this one the same way you did up above. 3 really means it's 3, no imaginary part. Well, the conjugate is 3 minus no imaginary part. Plus 0 minus 0, it's still 3. Okay, any questions on how you find conjugates? All right, so now let's take the idea of multiplication conjugates and put them together. All right. So let's try multiplying a number times its conjugate. Okay, and see what happens. Okay, so here's my number. Z is 3 minus 4i. And it says multiply it by its conjugate. What's the conjugate of 3 minus 4i?
3 plus 4.
3 plus 4i. Okay, let's distribute that out and see what happens. Okay, Dakota, what's the first thing I multiply?
3 and 3.
3 times 3, which is
9.
9. Okay, Jackie, what's next thing I would do?
4i.
3 times 4i, which is
12i.
12i. Okay, and Brandon, next thing?
You do negative 4i and 3.
Good. Negative 4i and 3, which is
Negative 12i.
negative 12i. And the last part, we have a negative times a positive. So that's a negative. And Zach, what's 4 times 4?
16.
And I times I?
I squared.
I squared. Okay, as I combine some of these like terms, what's going to happen?
Cancel out.
Yeah, we get plus 12i minus 12i. Okay, that's not a coincidence. If you multiply conjugates, that always happens. Every time. Okay. And now we have 9 minus 16 times I squared. Okay, what's I squared?
Negative 1.
Negative 1. So we have minus, another minus. Okay, what happens there? Becomes positive. So we end up with 9 plus 16, or just 25. Notice the final answer doesn't have any i's in it. That's the point of using a conjugate. When you multiply something by a conjugate, all the i's disappear. Okay, any questions on that? All right, so there's a way we can look at the problem very quickly. Okay, I can tell you the answer is 41. Okay, not because I've done it before, but I'm just looking at the 5, I'm looking at the 4. That's all I need to look at to do this whole problem out. Okay, let me show you what I did. What's 5 to the second power?
25.
What's 4 to the second power?
16.
And if you add 25 and 16, you get 41. Okay, let's multiply it and see how that works. 5 times 5. There's 5 to the second power. Now you've got 5 times 4i, 5 times negative 4i. What's going to happen there? That's going to cancel, so I'm not even going to write it. And then I'm going to get negative 4 times positive 4. Okay, that's negative 16. And then I times I. But what does that I squared do to that minus sign? Makes it a plus. Remember, I squared is negative 1. So I end up with 25 plus 16, which is 41. Okay, so the trick, if you want to use it when you're multiplying conjugates, just take the first number, 5, square it. Take the second number, okay, not the I, not the negative, just take the number. Take the 4, square it, add them up, and you're done. Okay, that trick only works with conjugates. All right, so let's say I had something like 3 plus 6i, 3 minus 6i.
45.
I didn't do it yet. Yes, you're right. 45. Does everyone see how he got 45? Okay. 3 squared is 9. 6 squared, 36. Add them up. If you don't like the shortcut, do it out the long way every time. And the i's are always going to cancel. But that's 45. Okay, so when we do division, I'm going to use that trick because it'll speed up part of the process. All right, so the whole point of looking at the conjugate is to do division. Okay, we're going to use the conjugate when we divide. Okay, and this is how you do it. So to divide two complex numbers, you're going to multiply the top and the bottom by the conjugate of what's in the bottom. Okay, so like I said before, division is really multiplication. So to divide two complex numbers, multiply the top and the bottom of the original problem by the conjugate of what's in the bottom. Okay, and one of the reasons we're going to do this is because you're not allowed to leave I in the denominator. Well, if you multiply by the conjugate, we saw what happens. All the i's disappear. Okay, so that's our goal. We're going to make all the i's disappear from the bottom. You know what? Actually, let's just do this one first. All right, so this one, it's not too bad, okay? Because what we have in the top is just a 1. And then in the bottom, we have 3 plus 4i. Okay, in example 6, we'll look at one where the top is a complex number and the bottom. Okay, for this one, we'll start out a little easier. Okay, so it says divide. So I'm going to multiply the top and the bottom by the conjugate of what's in the bottom. Okay, what's the conjugate of what I have in the bottom there?
3 minus 4i.
3 minus 4i. Okay, if it helps to put it in parentheses so you don't forget it's a distributive, go ahead and do that. Now the top is also a distributive, but it's the easy distributive. It's just 1 times 3, 1 times negative 4i. Okay, so is the top going to change at all?
No.
No. Anytime you distribute 1, it doesn't change. If that was a number other than 1, yep, it would change. Okay? So that's the top. Okay, now in the bottom, you're multiplying conjugates. If you remember the shortcut, it makes this very fast. So don't say it if you know it, just let people look at it for a second. Think about the first number squared, second number squared, and then add them up. Okay? Anybody think they know what the bottom's going to come out to?
25.
25. Okay, any questions on how we got 25?
Did you just do the FOIL?
We did the shortcut to FOIL, yep. You can also do FOIL and that'll give you the same answer. But it's 9 plus 16. All right, last thing we have to do is, this isn't standard form. Okay, standard form is real part and imaginary part separate. So to write it like that, take your real part over 25, take your imaginary part, and put that over 25. Okay, that's how you'd see it on the test. 3 over 25 minus 4 over 25. Real part, imaginary part. Any questions on that? All right, so we'll try one more division. This time we'll have a complex number in the top and in the
How
bottom.
do you do that? Yeah.
How do we do the bottom?
No. the final one.
This part? So for this part, all you do is take 3, put that over 25, copy down your minus sign, and then put 4 over 25. So you just take both of these numbers and put them over 25 separate. That's it. Same thing if you had something like, that's exactly the same as writing this. It's kind of reverse of common denominator. Instead of putting it together, you're separating it apart. Okay? So just take each number and put them over the denominator separate. All right. Let's try this one. All right, and this will be the last one for section A.4. So Derek, can you tell me what I would multiply the top and bottom by here? Not sure. Does it have something to do with the top part of the fraction, or are we going to do something with the bottom part? Bottom part. Okay, something with the bottom part. Who help him out? Just remind him, what do we do with the bottom part? It's almost the same thing. We just change one thing. Yeah? Yeah, just change the sign. Okay, that's the conjugate. So instead of 5 minus 12i, you're going to multiply the bottom and the top by 5 plus 12i. Okay, the bottom is always the faster one to do. So if you want to do that first, it's just going to be a single number by itself. Okay, using that shortcut, anybody see what the bottom comes out to?
169.
169. 5 to the second power is 25. 12 to the second power is 144. Add those two things up, there's the bottom. Bottom's done. Nothing else for the whole problem. Now the top, can we use the same shortcut? No. They're different numbers, you just have to FOIL the whole thing out. So we get 1 times 5. I get 1 times 12i. 5 times 4, which is 20, with an I. And now the last part, 4i times 12i. Okay, so if you want to do it in your head, remember what 4 times 12 is. And then remember what I times I is. So what's 4i times 12i? Callie?
48 squared.
Yeah, so we're going to get 48. Just move that over a little bit. 48i squared. Okay. What I'm going to do is combine my i's together. 12i and 20i is how much? 32i. And 48i squared is really what number?
-4.
That's a 48 times negative 1. Okay, last thing I need to do in the top is just combine together 5 minus 48. Okay, that's negative 43. All right, now is it okay to leave that? Is that my final answer? No, I got to split it into 2 fractions. Put the 43, negative 43, over the denominator. And what's the other number?
32i over 169.
32i, same denominator. Okay. That's it. So that's multiplying and dividing complex numbers. Okay. So any questions on A.4. Okay, so on the test you'll see one of each. Okay, you'll have one add, one subtract, one multiply, one divide. Okay, for complex numbers. All right, so last section for the week, which we'll probably look at part of it today, part of it tomorrow, is 5.3. Okay, so in 5.3, probably not today, but by tomorrow, what we're going to do is we've done polar, we've done complex. We're going to put the two together. And the idea is everything I just showed you can be done a lot easier. Okay, all that FOIL stuff, the I-squareds, I can make all that go away. We can do it a lot easier. Okay, I'll show you the trick for doing that tomorrow. Okay, we're going to start off with what's called the complex plane. Okay, so basically the complex plane looks kind of like the x and y axis, except we don't call it x and y. Okay, we call it the real axis, that's horizontal, and the imaginary axis, that's vertical. Okay, and on the test, you're going to have a couple problems where you've got a grid, and it's going to say graph 2 plus 3i. Okay, so you look at the real part, look at the imaginary part, and you graph it basically like it was the coordinate 2, 3. That's all you do. All right. So if my real part is 2, would I go left 2 or right 2? Right 2. And then what?
Up 3.
Up 3. That's it. That's the coordinate 2 plus 3i graphed on the complex plane. Okay. How would I graph 4 minus 8i?
Right 4 and down.
Yeah, right 4, down 8. That's it. It's 4 minus 8i. Okay, how about negative 8? Left 8. Okay, that's one that people mix up on the test. Make sure real axis, that's horizontal, and that's left. Okay, how about 5i?
Is that up 5?
That's up 5. Okay, so any questions? If I give you a complex number, ask you to graph it on the complex plane. How to do that? Okay, there'll be 2 questions on the test on this. Okay, questions? All right, last thing. All right, so last thing I'm going to show you how to do is write a complex number in polar. Okay. Now, since we're getting into graphing, okay, I know we've used the letters A and B quite a bit when we had complex numbers, and C and D. But when we start getting into graphing, sometimes X and Y makes more sense. So you remember, oh yeah, X is horizontal, Y is vertical. Okay? That's the only reason I switched to using X and Y now. Well, the way you've been writing numbers, this is rectangular form. Okay? Rectangular form basically tells you, you're graphing it on a grid. It tells you left and right movement. It tells you up and down movement. Okay, that's rectangular. Okay, what we're going to do is write this in polar. So instead of having a left and a right and an up and a down, we're going to have a radius. And what's the other thing we have in polar? Theta. Okay, we're going to have a radius and we're going to have an angle. And we're going to be able to reuse the same formulas we already know from earlier in the week. Okay, what's our formula to get x in polar? It has an r in it, it has theta in it, it's got a trig function somewhere. John?
R cosine theta.
R cosine theta, perfect. And what's our formula for y? R sine theta. Okay, so all I'm going to do, okay, I'm going to take my complex number, x plus iy. I'm going to take, and I'm going to plug that in for x. Okay, I'm going to take r sine theta, that equals y. And I'm going to fill that in for y. And that's going to give me a complex number, but it's going to replace the x and the y, and it's going to turn them into r's and thetas using the exact same formulas we already learned. Okay? Nothing new with formulas. So x is r cosine theta. Don't forget your I. And y is r sine theta. Okay. Now, what do both of these have in common in front of the trig functions? They both have an r. Okay, when two things have the same thing in common, we don't have to write it twice. We can just put it in front of everything. So we could have r cosine theta. And if I take an r out of the second part, what am I left with? I sine theta. Okay, so I did the reverse of the distributive property. Put the r in front. And that's the polar form of a complex number. R cosine theta plus I sine theta. Okay, and here's an example of a final answer. 2 cosine 30 degrees plus I sine 30 degrees. You don't do anything with that. This is what a final answer will look like. You find r, you find theta, and then you're done. If you were to take the cosine of 30 on your calculator and then multiply it by 2, what you'd be doing is changing it back. You'd change it back to rectangular. And then if you took the sine of 30 and multiplied that by 2, you'd be changing it back to what you started with, okay, which we're not doing. Okay, so that's what a final answer looks like. It's just an example. All right, so let's try to write square root 3 minus I in polar. Right, so here's our form. It is important you put parentheses around that because that r is distributed. Take away the parentheses, you just took out the distributive property. All right. Now, what are the two things we need to fill in here to write our final answer? What's the two things we have to fill in here?
R and theta.
R, and then theta is the same in both. Okay, so find R and find theta. We already have formulas to do that. This is what we did yesterday. Okay, what was our formula to find R? R squared equals what? X squared plus y squared. So we're just going to fill that in, and that'll give us R. Looking at this point, which one is x? The square root of 3. Okay, that's the real part. Remember the real part? That's your left and right if you were to graph it. Okay. Now, when you just have an I, they're not going to put the number in like I did. Okay, what number is always in front of I? It's always a 1, or in this case, it's a negative 1. Y is negative 1. You should not be plugging I in for either x or y. X is the real part. I is the imaginary part. Okay, so square root 3, negative 1. Okay, what's the square root of 3 squared? 3? Negative 1 squared? 1? So 3 plus 1 gives me 4. And what's my radius? 2. Okay, so I've got my radius. What else do I need to get besides my radius? I got to get theta. Okay, when we did this with real numbers, what did theta depend on? And it's exactly the same thing here, and it's exactly the same formulas. Okay, we have to know if you were to graph this. That's why I showed you how to graph what quadrant you would be in. Okay, so where would you be if you graphed square root 3 comma, -1. Yeah, square root 3 is positive. -1's negative. What's my formula for theta in the fourth quadrant? Inverse tangent. What's y in this case? Down 1. And then x? Square root of 3. Okay, so type that in, and then you'll know what your angle is. Okay, I'm gonna do mine in degrees. So inverse tangent, -1 divided by square root 3. Okay, so my angle is -30. They didn't specify what to do. So if they don't specify, I usually do degrees.
Could you type the same thing in for radians?
Yes.
That would give you the radians?
Yes, it would. The only problem is if you do it in radians, it's gonna go like this. Okay, that's correct, but I don't think a lot of people are gonna recognize that number.
Yeah.
Okay, so that's why I do it in degrees. And then if they want radians, I'll change it to radians myself. Okay, because this is an easier number to work with. Yeah. Okay, again, I just don't think people would recognize that. Okay, so any question on the angle? Okay, so now for your final answer, fill those two things into that formula. Okay, R cosine -30 plus I sine -30. Yep. Okay, any question on that? Yep, there's your angle, there's your radius. Okay, now I want to show you something. I want to take the cosine of -30. Okay, and let me go back to what I got in degrees. Cosine -30. Okay, does everybody see what I got there? 0.866. Let me take the cosine of +30. What did I get? I got the same thing. So it turns out if you end up with a negative in the cosine part, you can just get rid of it. Okay, it doesn't matter. Okay, on the cosine part. Okay, so if you have a negative angle in the cosine part, you can just get rid of the negative. Get rid of negative. And we're not going to get into the proof or the explanation why. I showed you with an example. Just get rid of the negative. So instead of -30, what would it become? Just +30.
We have to.
If you see an answer that's a multiple choice, I would simplify it. Okay, so you just need to understand this and this are the same. All right. All right. Let's see if same thing happens with sine. Okay, there's the sine of 30. Okay, let's try sine -30. Okay, did I get the same thing? No, but what's the only difference between the two answers I just got? One's negative and one's positive. So with sine, you can't get rid of the negative, but what you are allowed to do is move it to the front. Okay, you can't get rid of it, but you can move it to the front. So if you have a negative angle with sine, okay, with the sine part, you can move the negative in front. Okay, with cosine, you can just get rid of it. With sine, you can move it in front. So instead of a plus here, what would I have? Minus. Okay, and the reason why they do that is because when we work with angles, a lot of times people like to work with positive angles rather than negative angles. Okay, so these two answers are exactly the same thing. This one is cleaned up a little bit. This one's not. Okay, any question on those two rules? All right, I think that's good. Unless anybody need another one of that type. Let's do one more. Let's do a simple one. Let's just do 2 plus 3i. Okay, no square roots. Give that a shot. Try it on your own. Try to find the radius, find the angle. Then once you get those two things, write your final answer. Okay, this time I made it so you're not going to get a negative angle. You're going to get a positive. So you're not going to have to do that last step. All right, so our first thing we're going to do is find r. If you want to find theta first, that's fine. Anybody get an answer for r? Yep, square root of 13.
Can you put that in decimal form if you want?
Yep, if you want to put it as a decimal, that's fine too. Okay, or if you just want to leave it like this, that's also fine. Okay, so either way. Any questions on how you get r? Okay, just to keep it simple, I'll just leave it as a square root. Okay, it's about 3.6 if you do it out, I think. All right, and theta. Okay, what quadrant am I in? I mean quadrant 1, right 2, up 3. Those are the only things you should be using to find the radius. Okay, forget about the I. That's not part of finding the radius. Okay, it's just distance right, distance up. All right, so theta equals, what's my formula?
Inverse tangent of y over x.
Inverse tangent, y over x. Okay, if you're typing an I in for either your radius or your angle, you're doing something wrong. Leave the I out of it. Okay. All right. And last step, inverse tangent of 3/2. Inverse tangent. Okay. Anybody get about 56.31?
Yeah.
Yep, that's your angle. Okay. Now putting that together, can anybody give me my final answer?
Square root.
Yep.
Square root of 13. And cosine of 56.31 degrees. Plus, is it I sine?
Yep, I sine.
56.31.
Perfect. Okay, just remember to put that, it's kind of hard to see, but that's my parenthesis. And this time, I don't have a negative with the cosine, so I don't have to worry about it. I don't have a negative with the sine, so don't worry about that. Right, so there'll be 2 of these on the test as well. Okay, so 2 of these, 2 of the graphs, 4 of add, subtract, multiply, and divide. So that's probably almost half the test just on that material. Okay, any other questions? Okay, so homework, page 560, that's in the back. That's complex numbers, multiply and divide. 15 to 27 odd and 28. And then on page 333, this is the last thing we did, writing complex numbers in polar. 11 to 19 odd. Okay, I will be after school today. If anybody needs extra help, don't forget our test is on Friday.